Hi, my name's Toby, I'm a mechanical engineer, and today I'm going to be turning 3D printed plastic parts into metal. Or at least I'm going to try. I've never done this before. The process we're going to be using is called electroplating, or electroforming. I'm not really sure what the difference is yet. This process is essentially just electrolysis. You know, the thing you paid attention to in chemistry class, right? Well, in case you don't remember, then here's a graph.
Look at this graph!
Electrolysis is essentially the process of breaking down compounds via electricity, and it's how we do a lot of things, from harvesting hydrogen, removing rust, and electroplating. That's the one that we care about. Electroplating takes advantage of this compound breakdown to nab some of the metal ions from our solution and bind them to a part of our choosing. In theory, if I can master the art of electroforming jutsu, I can plate anything in metal. There's just one problem. I've never done it before, but how hard can it be? Looking online, everyone approaches this slightly differently, so I'm going to start with this video by Jeffrey Crocker. He makes it sound easy and he makes me feel safe. Aww. I will be making a couple of adjustments to his process to suit our circumstances, so stay tuned for that. To electroplate, we first need a few things. A sacrificial anode, I'll start with copper. The cathode we want to plate, our plating solution, more on that in a bit, and a power source. I'll use an old phone charger with these crocodile clips I got in China. Before we can start, I need to prepare our cathode. You see, electroplating works via electricity, so our cathode needs to be conductive, something these plastic Snorlaxes are famously not. No problem though, I'll just paint them in this welding primer that AI assures me is completely conductive.
Just trust me, bro.
A bit of plastic primer, and then a nice thick layer of welding primer. Yummy. I love the way it makes my throat and eyes itch. Now for our solution. The important thing here is that the solution contains ions of the same metal we want to plate with. You can buy these solutions pre-made, but I subscribe to the idea of buying cheap and then buying the more expensive thing later anyway. So I'm going to make my own. Jeffrey also does this using water, vinegar, and salt.
The vinegar ensures the solution is acidic, and the salt increases the conductivity of the solution. Both these traits are essential.
From what I've read online, during electrolysis, salt will produce mustard gas, and according to ChatGPT, 100% kill me. So, to avoid living through a live World War I bunker reenactment, I replaced it for hydrogen peroxide. I did this as ChatGPT assured me it's 100% conductive, a fact I'd later find out to be a total load of shite. I'm starting to notice a pattern with asking AI for help on these things. Anyway, with the solution now ready, I ran it through an electrolysis cycle with copper on both sides for about 2 hours. This will break down the copper in the solution, giving it a tasty blue color. And with that, I'm ready to electroplate! I simply submerged my annoyingly buoyant Snorlax wrapped in some copper wire and hooked it up to our negative power supply. Then I hook up the positive side to our anode and give them a few hours alone. And yeah, it didn't work. In hindsight, testing a copper plate on a copper painted part was dumb, but you can take my word that nothing has changed. This was annoying, but there's only one logical step forward from here. We make it bigger! Banana for scale. This time using nickel instead of copper, because I'm sure that was the problem. Yeah, it still didn't work, but it wasn't a complete failure. I had screwed on these brass brackets in hopes of weighing down my buoyant Snorlax. It hadn't worked, but as you can see, they had been plated in nickel. So the problem must have been the welding primer that ChatGPT recommended. Funny that. 1 second. Doing my own research this time, I find that most people use carbon paint or graphite paint to coat their parts. Both Hendrik and one of my favorite channels, The Craftsman, steady crafting, have great videos on this where they discuss electroplating and all different kinds of coating methods. I'll leave theirs and some other good videos in the description, but you better finish this video first. You hear me? Anyway. For my sake, there is only one coating I can buy in a spray paint can, and it's carbon conductive paint. This has to work. It even has conductive in the name. That, and Declan on Amazon gave it 5 stars, commenting that he used it for plating himself without any issues. Shout out to Declan. He also let me know that this stuff is crazy toxic, so I'll have to make sure to equip my respirator and safety sunnies. Thanks again, Declan. You're a real lifesaver. I got everything ready and set it off. This time I could see the part bubbling, meaning it was for sure conductive. But when I took it out,
I threw it on the ground. What you think I'm stupid?
I wasn't sure what was wrong at this point. I thought it might have been the metal anodes because they were seemingly changing color a lot and releasing a lot of contaminants. So I got some fresh copper and tried again, which broke, probably from too much ampage in the wire. So I got a more precise power supply and I fucking did it! Fuck yeah! So then, jobs are good and, well, not quite. See, copper is cool and all, but what I really want is that classic metallic silver finish. For this, nickel plating is the way to go. And if you remember, I had achieved this on a brass part earlier, but still couldn't get it going on my printed test pieces. So I decided it was time to get some proper solution. And you can see straight away how much greener it looks than the stuff that I made. And although I forgot to film it, you can take my word for it that this time the solution is actually conductive. That said, I got it hooked up at about 2.5 amps and set it on its way.
I did a shite job filming this bit, but I also got this fish tank pump to help keep the solution moving. This should help getting an even plating across the part.
The next day.
I mean, it has technically plated my rock, but it's done a pretty miserable job of it. The plating is flaky and not evenly coated at all. I noticed the copper wire had a layer of blue oxidation over it, which I thought might have been the problem. So I got some titanium wire and tried again, but the same result. A little deterred, I decided to try the copper plating again, only to somehow completely shit all over the solution. I don't know what on earth happened here. I mean, this is just gross. To top it off, the part hadn't plated at all. Who knew ass water wasn't a good plating solution?
Why are we still here? Just to suffer? Every night, I can feel my leg.
So, to recap, this is where we are now. The 3 horsemen of rubbish. Okay, calm down and relax. Work on some other projects for a while, enjoy a succulent Chinese meal, and get back to it. Looking back, the copper solution I'd made did work on a small scale. So obviously, something had gone wrong when scaling it up. Now, the go-to solution for copper electroforming is copper sulfate. And we can actually buy copper sulfate powder on Amazon pretty cheap, so let's get some of that. This stuff contains all the copper ions we need beforehand and is conductive, so no need for mustard gas salt. Nice. The next problem is acidity. Typically, copper sulfate is mixed with water and sulfuric acid to make our lovely blue solution. But I live in the UK, where it is nigh impossible to get sulfuric acid without special licensing. The same goes for battery acid or any other common acidic alternatives. But what I can get is white vinegar. If vinegar worked with our previous jerry-rigged AI hijack setup, then surely it will work with straight copper sulfate. Only one way to find out. Well, despite the fact that the air pump managed to turn the vinegar into a bubble machine, this seems to have worked out pretty well. I should also note I dropped the ampage at this part, which probably helped as well. Nice, that's copper down, but what about nickel? Well, other than topping up the solution with some vinegar, there isn't much else I can really do. But there's a reason I copper plated first. You see, as great as my carbon conductive paint is, it's nowhere near as conductive as metal. Hence why the brass part plated earlier when nothing else did. But now, my part isn't coated in carbon conductive paint. It's coated in copper, which is way less resistant and the champion of conductivity. So I'll just run the same nickel plating process using the copper plated part, and 2 hours later, hey, thanks for watching. If you enjoyed the video, then be sure to like, subscribe, comment, all the usual stuff. And yeah, I'll see you in the next one. Bye.